Hello everyone. In this video, we will learn how to solve for a system of two equations, two unknowns using algebra. Using algebra meaning that you can use substitution or elimination methods. With substitution, you will substitute one equation into another equation. With elimination, you can add or subtract the two equations. So for this example here, I am going to use the substitution method. Like I mentioned in previous video, that you can make a choice between substitution and elimination. They both related to solve for the two unknowns algebraically or using algebra. So eventually with more practice, you will realize either substitution or eliminations is suitable for the question that you are dealing with. So for this particular example, we have the very first equation as 3x minus y minus 3 equal to 0. The second one is 4x minus 3y minus 14 equal to 0. And what I'm going to use is I am going to use the substitution method. So when I use the substitution method, I notice that there is a unknown in here with the coefficient either minus 1 or 1. Okay, because with the substitution method, that means I have to solve for one unknown in one equation. So before I do this, I will again go back to the concept that I will label my equation. So I will label the very first one as 1. I label the second one as 2. So don't forget a reminder that when I label equation, I put a number inside the circle. A number appear inside the circle, that means it's representing the equation. So equation 1 is this one right here. 3x minus y minus 3 equal to 0. So what I'm going to do is, because I'm using the substitution method, I will, from equation 1, I am going to solve for y. Okay, after I solve for y, I will be able to take that whole thing and substitute into my equation number 2. Okay, so solving for y, this is what I have to do. So I am going to bring everything over to this side of the equation. So it will be negative 3x plus 3, right? Okay, now because solving for y, I must have y on its own. So I must divide both sides of the equation by minus 1. So whatever I do on one side of the equation, I must do the same thing on the other side of the equation, So then from here, minus y divided by minus 1 will give me positive y, because that's what I want to achieve, okay? You want to achieve the coefficient in front of y as positive 1. So this will give me y equal to negative 3x this is minus 3, I'm sorry. So this will be positive 3x minus 3. So this will become my equation number 3. Okay, so let me pause for a moment, because from equation number 1, okay, I will make it on the side here. So I will, okay, from equation number 1, I have 3x minus y minus 3 equal to 0. And from this equation, what I can do, which I avoided earlier, is that you can immediately solve for y by moving y over to this side of the equation. You see that? So you're moving y over to the side of the equation, you immediately change that into positive 1y equal to this. And basically, this is exact same as the one you have here. So it doesn't matter that you have y stay on the left side of the equation or y stay on the right hand side of the equation, you achieve the purpose of solving for y. So if I leave y on this side of the equation, I move everything over to the other side of the equation, I should have minus 3x plus 3, then divide everything by minus y, I still achieve the same purpose. Alright, so just to let everyone knows that sometimes you can quickly just move y over to the other side because basically they are the same. Okay, then you can solve for y right away. Alright, so the next step is I'm going to substitute y, this entire equation, okay, equal to 3x minus 3 into, that means I substitute equation 3, right, into my equation number 2, okay. So you take one equation, you turn it into an equation that has the unknown, okay, on one side, the rest on the other side. So if you turn 1 into 3, that means from 3 you substitute into 1. Don't substitute into the same equation again. Okay, so in this case, substitute y equal to 3x minus 3 into 2, I end up with this. So my equation number 2 is, I just want to write this down, okay, 4x minus 3y, and is equal to, if I bring 14 over to the other side, but I should not skip that step. I still should write minus 14 equal to 0. Okay, so from here, instead of writing y, I will substitute 3x minus 3 into where the y is. So where the y, I will write 3x minus 3. And from 3x minus 3, I turn this into one equation, one unknown, right? One equation, one unknown. So in solving for this, I must apply the distributive rule. So I can open up the brackets and collect the like term. So I should have negative 9x here, plus 9. Excuse me, I'm very sorry. Yeah. Again, take a sip of tea. Okay, so that will give me negative 14 equal to 0. And I collect the like term. This collect with that. I should have negative 5x. And collect this with this. I should have negative 5, so it's equal to 0. So then negative 5x equal to 5, right? Bring negative 5 over to the other side. Divide both sides by negative 5. So I have x equal to minus 1. Okay. After you have x equal to minus 1, you are going to substitute x equal to minus 1 into your equation number 3. Because your equation number 3, you already solved for y. So equation number 3, y equal to 3x minus 3, right? And then y equal to 3 times minus 1 minus 3. So here I should have minus 3, therefore I have y equal to negative 6. Okay. Then x equal to minus 1, y equal to minus 6 is the order pair, right? So that means I should have minus 1, minus 6 represent as an order pair, which is the solution for the system of two equations, two unknowns. So what we need to do is we need to check. Okay, we need to check. We need to check to see if negative 1, negative 6 is true for both equations. So from equation 1, what do I have? This is my equation 1. Equation 1 is 3x minus y minus 3 equal to 0. So I will check the left hand side and the right hand side. So left side equal to 3x minus y minus 3. So x is equal to minus 1. Y is equal to minus 6. So we have negative 3, positive 6, minus 3. So this will give me 0. And the right hand side is also equal to 0. Therefore, negative 1, negative 6 is the solution for linear equation 1. But you cannot just substitute to just 1. You have to substitute to equation 2 as well. So equation 2 is 4x minus 3y minus 14 equal to 0. So let's see if we have both sides equal to each other. Okay, so then we have 4. So right here I have 4. Instead of x I put minus 1. Instead of y I put minus 6. So this is my left hand side. So this multiply should give me negative 4, positive 18, minus 14. So this is true. So this is equal to 0. And the right hand side also equal to 0. Therefore, I conclude that left side equal to right side. So minus 1 minus 6 is the solution for this equation number 2. So it stays true for equation number 2. And up here, my left side also equal to my right side. Negative 1, negative 6 stays true to equation number 1. Therefore, I conclude that negative 1, negative 6 is the solution for the system of two equations, two unknown, that given to us as such. Okay. Alright. So I think I have enough time because each video is 30 minutes. What I'm going to do is I am going to work with another system of two equations, two unknowns, but for this particular one, I am going to use the elimination method. Okay, also using algebra, but I will concentrate on eliminate one equation from the other. So I don't know if I mentioned this to everyone, but when I said elimination, that means you can add or subtract the two equations. Okay, so how do we do this? How do we do this? Quite a question mark, right? Okay, so we can subtract one equation from the other. So in order for us to add or subtract, we need to realize the purpose of adding or subtracting. Okay, the purpose is that we are eliminating an unknown. right? You eliminate an unknown, so you turn it into a one equation, one unknown, so you can solve for that unknown, and then you substitute what you found into the other equation to solve for the other unknown. So apparently, your elimination methods somehow related to your substitution method. Alright, so let's get started. Again, I will label my equation. I will label the first one as 1, the second one as 2. Alright, so what I'm going to do next is I will take equation 2 and I multiply that by 2. Okay, so now this is when I would like everyone to pay attention. This is equation number 2 multiplied by 2. So the number inside the circle is labeled the equation itself. So this is my equation number 2. And I will take this equation number 2 and I multiply by 2. So that means you take 2, you multiply by 2x minus 3y plus 19 equal to 0 times 2. You must do it on both sides of the equation. And again, I will open this up by using distributive rule. So I should have 4x minus 9y okay 4x minus 6y. I'm sorry. Okay, so I put in so many years of teaching math. I am about to retire. So the older you are, more than likely you make an error. Okay, so 2 times 2x is 4x. 2 times negative 3y will give me negative 6y. 2 times 19 will give me positive 38. Okay, the other side is equal to 0 also. So I will call this equation number 3. Alright, okay, so what I'm going to do next, if I would take 1, subtract 3. Take equation 1, subtract equation 3. So at this time, you probably want to ask me this question. Okay, you want to ask me this, right? So why do I take equation number 2 and I multiply by 2 instead of multiplying by any other number? The reason I multiply this by 2 is because I want to have the coefficient of x to be equal to each other. See this, I turn into a 4x. And from equation number 1, I also have 4x. You have to have the same coefficient in order to eliminate that unknown x. Alright? Okay, so you can multiply by another number, but then that other number won't give you the same coefficient for the x. So then you have to do another step in order to keep multiplying to make sure that you have the same coefficient. So when you subtract, you eliminate that particular unknown. So I am going to write the equation 1 like 4x minus 5y plus 25 equal to 0. And I write the number 3 right below it, okay? Okay, so then what I do is I subtract the 2. Okay, subtract the 2. To be very careful. Okay, so this is my equation number 1. I subtract my equation number 2. So subtracting, you are going to put all of this inside the bracket, 0 minus 0 on the other side. Okay, before you can subtract, you must apply this negative sign in here. So I will have 4x minus 5y plus 25 subtract 4x plus 6y minus 38. is equal to 0. So now you see that you can eliminate the 4x and the 4x. So collecting the 2y, you should end up with just y, and minus 13 equal to 0, and immediately you can conclude y equal to 13. Okay, after you find y equal to 13, you are going to take y equal to 13 and substitute into either equation number 1 or equation number 2. Alright, okay. So what I will do in this case is I will substitute into 1. So equation number 1 is 4x minus 5y plus 25 equal to 0. So 4x minus 5 times 13 plus 25 equal to 0. So this I to solve for x. Alright, okay. So in this case I can solve for x. 5 multiply 13, so it gives me negative 65 plus 25 equal to 0. So combine these two, I should have 4x minus 40 equal to 0. So 4x equal to 40. So therefore x is equal to 40 divided by 4. It should give me 10. Okay, so 4x divided by 4, 40 divided by 4. Therefore, I have x is equal to 10. So the solution that I have for this system of two equations, two unknown, is 10 and 13, writing them as the coordinate, x and y. Okay, so the next step is we need to check, right? We need to check to see if this solution stay true to both equations. So you have to check in both. So in one. So one, the equation is 4x minus 5y plus 25 equal to 0. So I will put in 4 times 10 minus 5 times 13 plus 25. So this is my left hand side. Okay, so this will be 40 subtract 65 plus 25. So left side is equal to negative 25 plus 25, so it will be 0. So right side is equal to 0 also. So then I have the left hand side equal to the right hand side. So I am good for equation number 1. However, you need to check for both equations. You cannot stop by just checking for just one equation, because sometimes it's true for one, but it's not true for the other one if you make an error. Okay, so the equation number 2 is 2x minus 3y minus 19 equal to 0. So the left hand side is equal to 2 times 10 minus 3 times 13 minus 19, because is 10 and 13. 10 is x, 13 is y. So this is 20 minus 39 minus 19. So it will give me, this should be a plus 19. Equation number 2 is plus 19, is not negative 19. Yes. So excuse me, so I just want to correct here. Okay, plus 19. So this is negative 19 plus 19. So this is equal to 0. So my left hand side equal to 0. but the right hand side of the equation is also equal to 0. So left side equal to right side, and this solution is true for equation number 2. So therefore, I can conclude that 10, 13, the order pair or the coordinates, is the solution for the system of equation 2 unknowns. Alright, okay, I have the exercise for you to work on here. Alright, okay, so this exercise have two questions for you. It will be using elimination for this one and using substitution for this one. As you see that I tell you what method to use. So if you notice that I tend to use substitution if the coefficient in front of either x or y, either the x or either the y, the coefficient is either 1 or minus 1. So it's a lot easier if you have if you use substitution when you see something like this. So elimination is better to multiply one equation with a coefficient so that you can match the coefficient of either the x or either the y. So when you subtract, you then eliminate that unknown altogether. Alright? Okay. Thank you, everyone.